design process, as well as the methodology evolution in product design, as well as concurrent engineering. If I finish this three topics, so tomorrow I'll be designing about design for X, it is design for the excellence, then strategies and strategies for recovery at the end of the life. Okay, this another three topics will be remaining, and human factors in product design. We finish these three topics, okay, tomorrow. So that completes your module 2. Okay, so today is very important to understand about the product design process. Okay, there is what is conceptual design, what is embodiment design, detailed design. Okay, everything I'll be explaining today. So I'll wait for another 1 minute. Okay, because only 2 students are there. Tell others to join first. Okay. Anyway, I'll share the screen. Tell your friends to join first, Sachin. I'll go for okay. I was teaching about product design process, right?
Yes, sir. I think you had stopped at embodiment design, sir.
Yes, yes. So today I'll be explaining about what is the it is embodiment design. So okay. So what do you feel about to embodiment
So
design?
you stated a line that you will have product which will be divided into subcomponents. So I think in design engineer, a product will be broken down into multiple parts, and each
Yes.
engineer will be working on a particular part.
Okay, okay, good, Sachin. Anyway, okay, this that is embodiment design is very very important section because okay, so this is the this determine the overall layout design. Okay, that is how I should complete the how I should complete the product. Okay, what it may be new product development, or it may be the what you can say the advancement of new technology to the existing product. Both also okay, it will by going through this embodiment design, okay, you will get the overall layout design, that is general arrangement. So what is the see what are the materials, okay, what type of material we should purchase, or you can tell what type of equipment we required, what type of the machines we required, okay, everything. Okay, we should means we should indicate in this means embodiment design. Next is okay, the preliminary form design. There's component shapes and materials, so we can decide so what is the shape of the component. So I think I will explain you in the coming slide. Okay, coming slide about the shapes and all. So the component shapes and materials. So how should the component shape uh, should be presented. So everything we will decide in the we'll decide in embodiment design, as well as the production process. So what type the production means which type of the process we'll be using to manufacture the products. Okay, and solution for the function. So if you want to get the solution means if you want to give a new product for the society or for the customers. So what type of what you can say what type of new idea, okay, new idea or concept we are taking, and we are converting that idea into the prototype. So all these things, okay, we can analyze in embodiment design. So the concept is nothing, conceptual design is nothing but converting your ideas into the pictorial form, right? So in embodiment design, okay, we will convert that form and okay into the reality, that is converting your the sketch into the form of the shape, sizes, what will be the dimensions, what will be the materials that should be used for this application, or whatever it will be, everything we will decide in this embodiment design. Okay. Now, then we can, I think next week, if I see, I will be explaining about embodiment design detailedly. Okay, in coming slides. So whatever I told you, okay, everything is written here. We can see embodiment design is nothing but it is a part of design process starting from the concept of a technical product. The concept is nothing but your conceptual design. So once you get the customer needs, whatever the needs they are asking, okay, then we should go for the concept, right? After that concept of a technical product, then the design is developed in accordance with technical and economic criteria. What is technical and what is economic, Sachin? What do you mean by technical and what is mean by
The technical might be the dimensions and all those things related to that, and economical might be the price of the product or how it's like gonna be disposed, whether it's like good to the environment or not.
Okay, good, Sachin. So depending upon the application, okay, we will go to the cost. So cost cutting. So economic in economic criteria is nothing but the cost. So how much we are investing, so how much we should invest for this product. See, if you take the manufacturing of a car, so it is not simple because there'll be thousands of parts will be available. So parts will be there in a single car. So how much I should invest for each part, like the connecting rod, how much I should invest. So which is the material I should use, like cylinder. So what is the cost I should invest? What type of material I should use? So this comes under the economic criteria. That is about money. Okay. So technical is nothing but the Sachin told, right? The dimensions. So what should be the dimensions we should use for each.
Material selection, then for what application is required, and all those things taken into
Yes,
account.
yes, everything will come under the technical, the criteria, and you can go for next criteria and provides information to the detailed design. So detailed design will come later. Okay, I think next after the embodiment design, you can see the detailed design is coming into picture. So right now you understand the this embodiment design, then we'll go for the detailed design. Okay, after giving all this information, after gathering this all this information, we will send those things for detailed design. Okay, I will explain you this and in the coming slides. Okay, detailed design can lead directly to production. So after sending all the all these details for the detailed design, okay, then once it approves in detailed design, then directly it will go for manufacturing the products. Okay, so determining is nothing but whatever I explained you now. Okay, it's similar overall layout design. Okay, it will show the overall in which method I should in which method I should manufacture my products. Okay, which is the equipments, what type of material I'm using. Okay, what type of material I should use. So everything will come under the overall layout design. Then component shapes and materials, the production processes, then solution for an auxiliary functions. So if it function is nothing but the output. So for what sake I'm doing, for what sake, okay, I'm doing a new product development. Okay, function means reaching the goal. So whatever the customer is asking, whether my material, whether my product is functioning the same what they're asking. So if the customer is asking, I want a pen, okay, which the pen should write, the quality of the ink should be good. So that is called function. Function is nothing but they want a pen with high quality ink. So the company should reach that what the customer is asking. Okay, if the pen design is very good, the pen design is very good, but okay, ink quality is bad, then automatically the customers will be not satisfied. So that's called a solution for an auxiliary function. So the function is nothing but I should manufacture a pen with high quality ink, but the design is good, the design of the pen is good, the design the so when I see, when a customer sees the pen, okay, if so they can attract, but the ink quality is bad, then automatically the sales of the pen will be low. So that indicates whatever you give the solutions regarding to the customer needs, okay, it should function to the requirement. Okay, so you can see here in embodiment design. So here you can see that is one is conceptual design, okay, and later is detailed design. In between you can see this means embodiment design, right? Right, students? Hello, hello, students, can you hear me?
Yes, sir, your
Yes,
voice
sir.
is audible.
Visible, sir.
Okay. See here you can see whatever we are seeing here. So this part, the conceptual design,
Sir, you're
and
audible, sir.
okay. See whatever. whatever I have written here. Okay, there is conceptual design, there is embodiment design as well as the detailed design. Okay, you can see the same thing here, right? With the explanation. So conceptual design is nothing but a set of concepts has been developed and evaluated to a single concept or a small set of concepts for further development. So what is the meaning of this? So what is the meaning of this? The set of concepts
So
have been
based on the
developed.
problem statement, you just develop a drawing or design for the product without any dimension or all those things, just like for specific problem statements.
Okay, good. So see, this is the first step. Conceptual design indicates your design thinking. I'm telling you a number of times this the same thing. The conceptual design is nothing but as a design thinker. Okay, I will ask the customer needs. Depending upon the customer needs, okay, that is I will empathize them. Once I empathize them, I will get the needs of the customers. Then I will go for the problem statement. Once I write the problem statement regarding to the customer needs, then I should go for ideate. That is called brainstorming session. So brainstorming session is nothing but the conceptual design. Okay, whatever I get the ideas, okay, I'll write in the form of either writing, okay, in the words, or I will write in the form of the pictures. Okay, a set of concept means I want to develop around for the same problem statement. Okay, I will get around 1000 or 2000 concepts. So that is nothing but a set of concepts has been developed. So I first thing is they will give the time. The company CEO will give the time. Okay, I'll give around 10 days time to get the ideas. Okay, that's concept. Then all design thinkers will sit and they will try to analyze regarding to the problem statement. They will at least find around 1000 ideas. Out of that 1000 ideas, then that is concepts. Then they will select at least three. I told you, right? At least three. Initially they will select three. One by one they will go for test. So that is called evaluated to a single concept. So if out of that 1000 concept, okay, if only single concept is better, good, then they will take that single concept. So how they will take, depending upon the design of the product, okay, whether the design is good or not, whether the cost which is investing in the design is less, as well as the material which we are investing for producing each product, okay, is less. So they will compare everything, then only they will select at least three minimum. Okay, they'll select three good ideas, that is three good concepts. So this will come under the conceptual design. So when you go for next, there is your embodiment design. So here you can see first is finalize product architecture. Okay, what is this? What is this product architecture?
So is it the 2D drawing, sir? Like you just converting concept design into like a drawing on a computer
Yes, good Sachin.
with like
Good. So you can see.
separating them into as parts or like choosing the material and all those things, sir.
Okay, okay. Anyway, the next slide. Okay, I'll show you by in the figure. So this is called as, okay. This is called as your product architecture. This architecture.
Conceptual design,
Okay,
sir.
that is called as concept. If you take example right now, there's a COVID. So public hand washer. Okay, if you want to develop a public hand washer, so this is a concept. Okay, what is developed? See here you can see the valve is there, the pump is there. Why they will use the pump? Okay, to pump the water from the water tank to the valve. For that you want pump. Okay, there will be switch. If you on the switch, okay, the pump will the motor will launch. See here you can see there's a battery, there's a pump. When you on the switch, okay, the motor will be means connected to the pump. The pump will suck the water from the water tank to the valve. So here you can see the soap oil is there. Okay, and here, okay, we can use the soap oil and we can wash our hands. So this what you can say, the water, okay, the wastewater will go to this collecting tank. Okay, this is about a concept. Okay, this is called as a concept. So this initially, okay, we should write in the form of the picture. You can see this is called as what you can say hand sketch, or you can call this as the not this sketch prototype. Okay, it is called sketch prototyping. So if you go for design thinking, so a word called a sketch prototype. Okay, first initially we should write this sketch prototype. Here you can see there is no dimension, right? So here they are not mentioned any dimension, right?
No, sir. No dimensions are mentioned, sir.
So no
Even
dimension.
materials are not mentioned.
Yes, see here they will not mention which material I'm using for if you take the basin, which material I'll be using for wastewater collecting tank. So they will not mention anything like which material I am using, and what is the dimensions. So what will be the material which will be used for different sectors. So nothing they will tell. Only they will write the concept. One sketch they will write. First they will write in the form of the writings, the theory. Then they will convert the theory in the form of the sketch prototype. So this is called a sketch prototype. Here I can, this is called as rough sketch product architecture. So this is nothing but first process. Okay, in the embodiment design, first is nothing but the what you should do, that is the product architecture. Okay, this is first process in the embodiment design. I think everyone has understood right now. What is first one? Finalize the product architecture. So you should write, see, writing the 1000 ideas. In the 1000 ideas, select best 3. Then after selecting 3, you convert that idea into the reality. Reality is nothing but the sketch prototype. I think everyone has understood now. So convert that concept into the sketch prototype. Next, if you see, determine form and shape of the parts that will be satisfied required function. What is the meaning of this?
So it's like providing certain limit, like how big you need the washing basin, like for the product, like to be used for a particular application. So you need to at least say like what shape of product you need, or like what dimension of products you need, at least like a range.
Okay. See here in the determine form and shape of the parts that will be satisfied required function. So anyway, required function is nothing but according to the customer needs. Customer needs, okay, we should satisfy them. So according to that, okay, we should fix the size, and means we should fix the dimensions, and we should fix the materials. Okay, we should fix the materials. We should fix the shape of the material. What is the dimensions of the parts? So if you see here, if you go for this, so there are a number of parts, right? So there's a basin. Okay, this is another part. If you go for wastewater collecting tank, so this is another part. If you go for the pump and the pipe, okay, which is connected from the water tank to the valve, so that is one part. So the water tank is another part. So we should finalize this shape as well as the dimensions for everything, right? Without doing all these things, we cannot go for manufacturing, right? If you have 2D drawings, then only we can go for manufacturing, right? So right,
Yes,
students.
sir.
So anyone has any doubt in this? So this is
No
the
doubt,
second
sir.
step. This second step, that is determining the which form as well as the shape of the parts. For each part, we should give the dimensions for that, and which material I will be using, as well as what should be the dimensions. Everything we should define here. Then last you can see the quantify important design parameter. What is this quantify important design parameters?
So is it like the tolerances, like assume for certain parts you need to get in this range, like 5 mm to 6 mm, like that?
Okay,
So it
good.
to fit into a particular part, like different parts should be joined. So they should have a set amount of tolerances and limits. So within that, they can fit and properly function.
Okay, good, Sachin. So that's the thing, but the tolerances which we should give for the each part. So if you go for assembling, so first we'll manufacture each part, then we'll go for assemble. So in assemble, okay, always you should remember that if you go for industry, they will give the tolerance for each part. If you go for shaft, they will tell we want 25 plus or minus 0.01012 to minus 0.01. So that indicates, okay, the diameter of the shaft should be either 25.001 or 24.009. So there is nothing but tolerance. If it gives 0.1 mm, so 25.1 mm, either the diameter of the shaft should be 25.1 mm or 24.9 mm. So that is the ultimate tolerance. So those things, okay, you should specify neatly. These things will come under that is your preliminary or embodiment design. I think everyone has understood what is this embodiment design, right?
Yes, sir.
And last is detailed design. So once you do all these things, then you will send all these informations for the detailed design. In detailed design, you can see preparation of detailed technical drawings. So here in the embodiment design, okay, we will finalize the dimensions, okay, shape, dimensions, everything we will finalize. We will give the dimensions for that. Okay, then we will send all this information for the detailed design. In detailed design, okay, they will make pakka, means they will finalize these drawings. That is called as preparation of detailed technical drawings. So they will convert all the information what you are giving in the embodied design to the technical drawings. They will convert all this what you are giving the information, they will convert into 2D drawings. Okay, then material information. So which type of material we will be using. So that's called as bill of material. If you take the bill of material for each part, everything they will mention in the bill of material. So what should be the material that should be used? Okay, whether the material quality should be this. Okay, you should use this material. Okay, then you should it means after the manufacturing of the part. Okay, you should do some coatings or not, or you should do some hardening. So everything, okay, will be mentioned in the bill of material. And last is deciding on manufacturing operations, that is in which machines, okay, I should means I should operate, or I should manufacture the components, or I should manufacture the products. So this is about the detailed design. In detailed design, everything we should specify the technical, the detailed technical drawings, as well as the material information, giving the bill of material, as well as the in which process, okay, we should manufacture the products. This comes under detailed design. So anyone has any doubts in this?
No doubt, sir.
So I think this is a sketch, okay, which involves the process, okay, from the design thinking phase to the detailed design. Okay, that is converting your concept to the what you can say, the 2D drawing, finalizing the 2D drawing. Okay, till that you can see define problem to detailed design. So first you can see the conception design. In concept design, you can see define problem, gather information, concept generation, then evolution of concept. Same, okay, empathizing the customer. That is after empathizing the customers, you will get the means you will define the problem, right? So right, students.
Yes, sir.
So after that, gather the information. So about the product, you gather the information, then generate the concept generation. Okay, that's the thing. But you can see the brainstorming session. The brainstorming session you can do, and you can get the information. Then go for the means evaluation of concept. Means you should analyze, okay, which concept is good or not. See, you can develop 1,000 concepts. In that, okay, at least you should select maximum 3. Okay, in the company. So you see all the teammate, okay, will sit there, and and they will try to analyze which concept is good. So at the end, they will select at least 3. Then you can see you will get the means embodiment design. That is your product. That is product architecture. Whatever I told you now, arrangement of physical elements to carry out function. So what are the parts you need? Okay, what are the parts you need to convert your to manufacture the product? So example, if you want to manufacture the pen, so what are the materials you require, and what is the shape? So everything, okay, we will decide in this embodiment design. Okay, from the initial stage to final stage. So first we will select what material I should use, what should be the design of the product, and how the design should it should look. Everything, okay, we will start from product architecture. Then we'll go for configuration design. You can go here. Yes, you can see what is configuration design. Can anyone tell me? There's preliminary the selection of materials and manufacturing, modeling and sizing of parts. Okay, this will come under the configuration design. After configuration design, you can go for parametric design. In parametric design, you can see robust design. What is robust design?
Sir, like it should be what do you say, good product, sir, like strong or something like that, sir.
Okay, just this robust indicates a better quality product. Okay, I told you in the first module, right? See, robust indicates the quality of the product should be very good. So that is called as robust. And you can see tolerances. So what if you want to, if you require some tolerances, okay, we can give tolerance for the product, as well as next we can go for the final dimensions. So then you should finalize the dimensions. Then we should go for design for manufacturing, right? So at the end, you can see all this information, okay, will send to the detailed design. Okay, so so when you send all these details to the next section, that is detailed design, then they will finalize the drawings. Okay, they will finalize drawings, specifications of the product. Okay, then which method, in which equipment or which machines I should use to convert my raw materials into finished products. Then everything they will decide in the detailed design. So anyone has any doubt in this?
No doubt.
There is nothing but, okay, selection of material. Okay, which type of material I should use in my product. Okay, and which method, okay, I should follow. Everything they will write here. Okay, in the configuration design. I think next slide. Okay, you will get to know about the configuration design. I will explain you neatly. Next, see whatever I told you, okay, it is in the form of small sketch. So embodied design is is there. First is product architecture, second is configuration design, and third is parametric design. What they will do in product architecture, see component and sub assemblies. What is sub assemblies, students? What is sub assemblies?
Sir, sub-assemblies, I think it's like between parts, no, sir, like not complete
Yes.
assembly, just like between two, like the closely related parts.
The example, if this is a prompt statement, okay, to prompt statement is the customer is asking the public hand washer. So what are the components and what are the subparts? Okay, you want to assemble in the product. So these are called as subparts, right? Your battery, your pump, your
Yes,
basin,
sir.
your wastewater collecting tank. So these are called as sub assemblies. So component is nothing but you should fabricate or you should manufacture the public hand washer. So what are the sub assemblies? Sub assemblies is nothing but subparts. So what see for manufacturing a public hand washer. So what are the things you are adding to that? You want pump, you want switch, you want valves, you want water tank, you want batteries. Okay, everything you require, right? So this is called as subparts. So in the product architecture, okay, we will decide the component, okay, as well as the subparts in the product. When you come for the configuration design, so here you will decide the shape and dimensions, okay, then specific material, then selection of standards. So I think I told you, right, ISO standards in your first module for quality. So there will be some standards will be there, right?
Yes, sir. You even gave certain numbers, sir, like one
Yes,
for
yes.
quality, other like 4,000. You gave some numbers like that, sir.
Yes. That is 1300. So that is for quality. I'm telling you. That's called standard. There's selection of standards. Always you should mention the selection of standard for every material. That is called as quality for quality purpose. Okay. So we should check if you take element. Okay. In the backside you can say ISO. They'll mention ISO. Okay. That's called Indian standards. So always you should always you should mention what is the standard of your product. Next, modeling and simulation. This you know, right? Whatever you done in ANSYS. So we should model first, and we should try to analyze that doing the by solving the problem by using the ANSYS or Abacus or Maston or Pattern, whatever it may be. First you model by the design software, then you do the analysis. So this you should do in configuration design. After that, rapid prototyping. What is this rapid prototyping?
Sir, is it a 3D printing, sir?
Yeah, that is our 3D printing. So we can use rapid prototyping for manufacture the products. So after modeling and simulation, okay, if you agree that the product is withstanding the load, or it is okay, then we'll go for manufacturing some one or two or three. See, we will manufacture on 3 or 4 products initially. Okay, we'll not go for manufacturing the products to check whether that is for testing the product. See, after doing the modeling and simulations, finding the results, okay, we'll manufacture 1 or 2 products, okay, to see whether the material is withstanding the load or not, whether the material quality is good, whether if I use this material, okay, the material quality is good or not. So everything to check, okay, we'll manufacture 1 or 2 products. So that is called rapid prototyping, okay. Or we can go for CNC machines to manufacture the products, whatever it may be, the process or the or you can say the method, which method you are using to manufacture the products. Okay, here they mentioned the rapid prototyping. You can go for the any machines. Okay, so this is called as that is configuration details. Okay, you should mention each and every part, the shape and dimensions, the specific material, which material you'll be using in this part, as for standard, so the selection of standards, then modeling and simulation. You should do analysis to get the results. Once you get the results, okay, then you should go for manufacture the 1 or 2 products. Okay, why? To test your prototype. So when you come for parametric design, here you can say optimization technique. What is this optimization technique, students?
Sir, like earlier you told no, sir, like it's just improving the design. Like assume there's like unwanted material, like there's no stress or less stress concentration area. So you can exclude that part and reduce the weight of the product. So it's just like following those steps and reducing the amount of material required to make the product, or like just improving the design by like doing some test, like you said, no, sir, stress test and all those things.
Good, Sachin. So once we do the once we manufacture the product, then we will go for the testing. In testing, if you got that, okay, we can remove some excess material there. Okay, that's called optimization technique. Optimization is nothing but optimization your product or design, your design. Okay, you will try to optimize. Either you will remove the excess material wherever the stress concentration is less, wherever the stress is less. So that is called optimization technique. I'll explain you in coming slide. Okay, I'll show you one slide now. So next is evaluate the design. So once you do optimize, again the design will change, right? Once you remove the material, so what happens? Again your design will change, right?
Yes, sir.
So once the design changes, again you should go for modeling and simulation. So again you should go for modeling and simulation. Again you should apply the force, and you should find the stresses. Okay, so that's called as evaluate. So once you change the design, okay, then again you should go for the modeling and simulation, do the analysis part, and get the results. Then go for the rapid prototyping, means manufacture the product. Then again come for the optimization technique. If the product is very good, then leave it off there itself. Okay, again if you want to optimize, you can optimize once again, then go back again to modeling and simulation, again manufacture a new product, again to means come to the means evaluation of the design. If the design is okay for you, then go for examine the design. Once you got the results is good, then we will go for the manufacturing of the products and we'll supply that product for the customers. So this I explained you, right?
Yes, sir.
So this is called as product this is called as product architecture. So this is very important. So when you work under product design engineer, okay, you want this idea. So when your CEO comes and tells you something, okay, regarding we should manufacture a product, whether it may be example, this is an example, public hand washes. So something like that, if he gives, immediately you should write down the sketch. That is called as your hand to rough sketch, or it is called as the prototype. Okay, the sketch prototype, you should first write your sketch prototype, then only you should convey that sketch prototype to the others, that is other heads, other department heads. If they're accepted, then only you can go for the you can go for the next step. Okay, next step indicates the rapid prototyping. But that's your 2D drawings. Okay, I think this is very important. Try to analyze this steps in configuration design. So when you go for the industry, okay, this is very important to analyze this. So first is review the product design specifications. What is this? Students, can you see the slides?
We can see the slide, sir.
So you can see at the right part. Okay, right part. Okay, so this is a product. For what purpose they'll use this product?
So are those hinges, sir?
Yes.
So it's used between the doors, sir.
Doors will be there, or fixing the TV, right? Fixing the TV will use
Yes,
this.
sir. Yes, sir.
So mainly the fixing the TV, they'll use this. What I can say, these types of hinges. So first, so here you can see there are four different types of hinges are there. Okay, to fix the TV. Okay, this is called as bracket. For fixing the TVs, we'll be using this. So first when you want to develop a new product, okay, like this bracket, then the first step is review the product design specifications. So once you go for the conceptual design, okay, next is nothing but the embodiment design. In embodiment design, so we will design the architecture, right? These four figures we'll write first, right? By using ant sketch, right? So right, students?
Yes, sir.
So so that's completed, then we'll go for the sizing. What will be dimensions, and so what will be the material, everything we will decide in the configuration design, right? While doing this configuration design, kindly see these four types different designs. Okay, see, first step is review the product design specifications. Okay, we should review what is the specifications of each product. Means there are four different modeling, four different models. So first we should see the different specifications for each model. Second, you can see the establish the spatial constraints, human constraints for maintenance. What is this? What is second one? The second point tells us. Anyone?
So 1 minute, sir. Establish spatial constraint, human constraint, and maintenance. So is it like you need to design a product in such a way that it has a long life, sir, and should not have much of maintenance?
Okay, good. Good, Sachin. Anyway, so this is regarding to the constraint. So depending upon the application, for what application we are designing the product. Okay, so that is one thing. Spatial concern is nothing but for what application we are doing. Human concern is nothing but about the cost. So cost. So human is nothing but cost, right? How much cost we are investing. So what is the how much raw material we are buying for manufacturing each product, right? So if you take, there are four different types of products, right? Same. The purpose is same. That is means fixing the TV. Okay, the purpose is same, but so there is a different four designs right there. So for the four designs, how much cost I should invest, how much raw materials I should purchase, everything will come into picture, right?
Yes, sir.
So next the third step is, okay, create interface or connection between the components. So for this, which component is attached? TV, right? Example, I'm telling you TV, right?
Yes, sir.
So which are the mechanisms or which are the components, okay, which will be attached to this component, which that is your bracket. For this bracket, we will be attaching the TV. Okay, this is called as mechanism design. What you done in com, okay, 4-bar mechanisms or whatever it may be. So we will attach the TV, okay, to this bracket. Okay, we should see in the that is called as third step. When you come for fourth steps, try to combine or eliminate parts. So this is nothing but, okay, wherever, that's called optimization techniques. What you said here, optimization techniques, right? So optimization techniques will come here. Try to combine or eliminate parts. If you want to eliminate, okay, the parts you can eliminate. Okay, how you can eliminate, okay, in further the fifth, sixth, seventh, okay, it means you will get to know. And fifth is, think about using standard parts, then special purpose parts. Okay, what is that standard parts?
So I think part that can be used for like multiple application, like screw, nut, and bolt, like those things, sir.
Okay, good, Sachin. So anyway, so here you can see the holes, right? Say for everywhere in the different component, okay, you are having hole. He is telling you use the standard size, so nut and bolt. So then it will be easy. So if you use special purpose nut and bolt, like if the standard bolt size is to like 3 mm, 3 mm, okay, then if you manufacture, sorry, if you make a hole of 3.2 mm, then what happens? So it will be difficult to find the 3.2 mm nut and bolt, right? Example, I'm
Yes,
telling you.
sir.
So that is called standard parts. So always you should use the standard part which will be available in the market. So like a nut and bolt. So you should see, okay, what is the standard of nut and bolt, like 3 mm or 4 mm or 5 mm. So that is called fifth point. Fifth point, always you should remember, when you are manufacturing any products, you should go for standard size. You should not go for special purpose parts, because if you go for special, again you should invest for that also to manufacture the nut and bolt. So only he's telling, go for standard parts. Then go for next sixth point. You can see alternative configuration of each part. So this is called as alternative configuration. So that is nothing but for a same what you can say, for a same problem, find a different design. So here you can see there are four designs. You can go for fifth design, or you can go for sixth, or you can go for 10 designs, 10 different brackets. Okay, so find alternative design for that application. Next, go for seventh step is analyzing alternative configuration of design. In that, product design specifications, design for function involves concepts. Okay, here you can see concepts of mechanism of material and machine design. I think everywhere, if you go for industry, okay, you should do the stress analysis. Okay, either it may be linear or non-linear, or it may be the fatigue, or it may be the creep, or it may be the fracture. Okay, everything will come under the mechanism of material and machine design, right? So depending upon the application, so what type of load it will be acting here, in the bracket, anyone can tell me? So when you fix the TV for this, what type of load will be acted?
Sir, is it tensile load, sir?
Okay, after the tensile load,
Shear.
shear. Okay, then,
I think that's it, sir. Those two only, sir.
okay, so that is called a static loads. So maximum the TV weight may be around 40 to 50 kg. The 50 kg load will be acted on the bracket, right? That's all. After that, there will be no fatigue load. There will be no creep load. Nothing load will be acting on the bracket, right? First, you should understand. If you go for industry, any industry, if you're working in some department, you should understand depending upon the application. If you attach a TV for this bracket, only the maximum what you can say, only maximum that the load may be coming about static load. Okay, a constant load will be acted on this bracket. Okay, then you should do the analysis. Then you should go for FEA, that is finite element analysis. So create this bracket, apply the TV load, okay, on the bracket, and find the stresses for all the four different brackets. Can anyone tell me for which bracket you will get the less stress?
Sir, is it I not sure of the less stress, sir, but I think it's for the second one, sir,
Okay, good.
because they have
Sachin.
removed the sharp edges, so stress concentration will be less in that.
Okay, good, Sachin. It's good. Answer is correct. Your second design, okay, is better than all the other designs because as Sachin told, okay, there's no corners. If there are no corners, okay, the stress concentration will be less. So only he has removed, he has done the optimization process. You can see, okay, in between the horizontal surface as well as vertical surface, okay, he has removed some material, right? So
Yes,
this
sir.
so this indicates he has done the optimization process, and he has got less stresses there. Okay, so that only he has removed the excess
Sir, and
material.
one more thing, sir, less material required to make it, sir.
Yes, less material. So only out of these four different brackets, okay, select the second bracket for manufacturing. Then go for the eighth step is evaluation of configuration design in that quickness to finish the job. If you take these four different brackets, the second bracket you can finish fast, right? Because material so there's no material excess material here. Sorry,
Sir,
they removed
based on
the
that, I think the first one is the easiest, no, sir.
easiest is first one, but see right now the the what you can say, the equipment or the machines, okay, are very good. Okay, whatever the process, okay, it will finish within less time. Previous, I think 50 years back or 40 years back, it was very difficult because we were using only traditional method, right? So
Yes, sir.
now you have the advanced machines. So within 30 seconds, okay, they'll finish this operations. Okay. So next is economy to produce. So second design, okay, because of removal, okay, the investment of the raw material is less, as well as the cost. Okay, the cost also it will come less. So like this, okay, like this, if you go for industry, they will follow these 8 steps. Okay, 8 steps to finalize the product or to finalize any application, any product. Okay, they will do this 8 steps. Okay, if you go for industry, you should follow this 8 step. I think I will share the slides. I will share this PPT for you. Kindly keep it with you. Okay, it's very, very important. You should know. Okay, if you want to select any product, what is the process? Okay, this is the process of configuration design. If you go for second one, see, I think you have seen the configuration design, right? See, I have explained here in the 4 points. See, these 4 points, you should remember all these things. Any doubts in this?
No doubt, sir.
Okay, good. Next, we'll go for the methodological evolution in product design. Okay. So if you have any doubts in this, you can ask me. The product design process. After this detailed design, see, once everything is finished, okay, in the embodiment design, you will send the process, the all the details for the all the details to the detailed design. In detailed design, they'll fix the dimensions, they'll fix everything. Then they'll go for manufacturing the product. Here you can see the product documentation on then the top. So they will finish the products. Okay, then they'll go for evaluation. Okay, getting the feedback. Okay, then if you want to change some design, again, see, this evaluation will go for the concept design. You see here in the down, you can see changes and improvement. If you want to improve that design part, or if you want to improve the quality of the product, or if you want to improve the price of the if you want to remove, or if you want to uh, relook into the price, again this evaluation process continues. Okay, again it will come back to the concept. Again, you should go for concept, then embodiment design, then detailed design, and evaluation. I think everyone has got a, so everyone has understood, right?
Yes, sir.
Okay, so this is about the product design process. So here, the main thing here is after conceptual design, how you will conduct the embodiment design is very important. Okay, in the design thinking process or design process, product design engineer. Okay, embodiment design is very important. From embodiment design, what are the information you will get and what you will send to the detailed design is very important. Okay, here if you do 99% accurately, then your product will be very good. Okay, if you do something wrong here in the embodiment design, then automatically in the evaluation process, okay, your product fails. Again, it will come back to the conceptual design. Okay, so this is nothing but your product design process. So in the notes, I'm telling you in the notes. Okay, only you can see this what I can say, it's sketches, but you cannot see this theory part. This and all, okay, it's not there in the notes. I'll send you the PPT. In PPT only you can analyze everything. Okay, students. So
Okay.
in the notes, okay, you will be not getting the sketches. Okay, these sketches I will provide in the presentation. Okay, then methodological evolution in product design. What is the meaning? What is the meaning of methodological means evolution in product design? Can anyone tell me? Anyone? What is the meaning of this methodological evolution in product design?
Sir, like as per the technology is evolving, you need to change your product to meet the current requirements.
Okay, good.
So
So
just like from normal machine, washing machine, it became smart washing machine. So like that itself.
good, Sachin. So this is nothing but okay. This methodological evolution is nothing but okay. We should use simultaneous or integrated design product process to complete the task. If you want to complete the task, okay, or complete the product, okay, within this time. So all the department, okay, they should sit in means they should sit in a single room and they should do everything means every department that should be there in the room and they should take the decision, okay, within less time.
So
So that is
concurrent engineering, sir.
so that's called as concurrent engineering. So right now this is methodological evolution is nothing but okay. Previously, I think last 50 to 60 years back, they were using the traditional technique. That is nothing but see, once the design thinking process is over, then the product design engineer, okay, he was getting the details of everything. Then after that, the product design engineer, okay, he was doing the design process. Then he was sending the design process for the design engineer. Then he was doing means he used to convert the design to the 2D model. Okay, then 3D model. Then the 3D model will be given to the then the 3D model will be given to the what I can say, the analysis team. Okay, like that. So this is called as the traditional process. Okay, the traditional one. From one after one process is completed. Okay, then it was going for next. But right now in 2000, from almost from next last 20 years. Okay, last 20 years, okay, all the teammates or you can say all the departments, okay, are sitting in the same room and they're trying to analyze, okay, simultaneously. I means at the same time they're doing everything. So only here you can see. I think next slide. Okay, here you can see. We can here you can see when I okay, here you can see the time taken is less, right? In the concurrent engineering.
Yes, sir.
So right now, from last 20 years, okay, they have removed that traditional process. Means after one process, okay, they're sending the information to other departments. So right now, okay, it is not like that. So all the department heads will be sitting in the same room. So once that the design thinking team is completed, okay, the process immediately everyone will analyze whether the design is good or not, whether whatever he has given the solutions it is good or not. Everyone will decide. But previously in traditional method, okay, only the design thinking team was sitting there. Okay, they're finalizing the product. Sorry, they're finalizing the design. Then the design will be sent to the product design engineer. Last 50 years back. So that is called traditional method, which is flowing from one to one. If you see here at the top, see the idea. Once the product design engineer I think you can see the second figure. Don't see the first figure. See the second figure. The idea generation. This is nothing but the design thinking team. So once they give the idea, the concept, then it was going the design, that is concept to the product design. Then that is product design engineer. So he used to convert the concept into the drawing, that is product architecture. Then the product architecture, okay, you will send to design engineer. You will convert that concept design to the actual design by using the software. Okay, you will convert 3D. Then after that, you will send for the analysis team. Then they will check. Okay, if it is okay, again they will send for the product design engineering team. Okay, this design is okay, then they can go for manufacturing. Then after that, the product design engineer will send the final design for the manufacturing department. The manufacturing will do the manufacturing, okay, of each parts. Then assembling team will be there, assembly team. Then all the parts will be going to assembling team. Then they will assemble. Then they will send the product for the market. Okay, if there's any maintenance, okay, then they will do some maintenance. So this was the traditional method. The first process is called as the traditional method. So after finishing one process, then so that will be continued by others. But when you see the concurrent engineering or the new method, the evolution, okay, which has happened from last 2 years, means last 20 years is, okay, all the department heads will be sitting in the same or taken same room, and they'll be deciding at that particular time. See, idea generation, see, every manufacturing department head, assembly department head, maintenance head, as well as the design thinking head, the product design engineer, everyone will be sitting in the same room, and they'll be analyzing whether I can finish the task, uh, whether I can manufacture the product within less time or not, how I can manufacture. See, once the idea is generated, immediately all the four heads will see the idea generation, or you can see the concept. I think everyone is getting right. Anyone has any doubts in this?
No doubt, sir.
So this is called simultaneous or integrated design. So at that particular point, everyone will be sitting in the same room, and once the concept is generated, everyone will look into that, whether this concept, if this concept is developed into the product, whether that product will be that product will sell well in the market or not, whether this design is good, whether the concept is good. Everyone will decide, and then only they will go for the next process. So that is design. After the design thinking process, that is concepts, then the product design engineer will sit, and he will analyze, he will make a design, and he will show for all the department heads at the particular point. So everyone, if they agrees, then it will go for the analysis team. Okay, and immediately he will do analysis, and he will send to the results for the design thinking, uh, design engineer. Okay, product design engineer. So and the same way, everyone will be there in the same room. So the manufacturing engineer will see the results, and he will tell whether this product is good or not immediately. So immediately, see, at that particular point, everyone will decide, and then they will go for manufacturing. So that at the end, you can see at the end, by using this concurrent engineering, okay, we can reduce the time to manufacture the product, and we can supply, or we can tell, we can send the products very early to the market. So this process, see, for developing of new product, this concurrent engineering is very important. If you want to develop a new product, and if you want to send for the market, to the customers, okay, you should follow this concurrent engineering. Okay, it's very important, so that we can reduce the time, and we can supply the products very early to the market. Okay, so this is about concurrent engineering. So anyway, I will explain methodological evolution, these 5 points. Okay, and as well as the concurrent engineering, I will explain about these 3 points tomorrow. Okay, so then we'll go for the next, that is design for X. Okay, so anyone has any doubts regarding today's class, they can ask me.
Sir, DFX is basically designed for manufacturing, designed for assembly, and all those things, no, sir?
No, DFX indicates for design for excellence. So
Excellent. Okay, sir.
if you want to develop a good product or excellent product, so what are the things you should consider? So so that is called as design for excellence. Okay, if your product should be very good, or it should be the customer should be satisfied with respect to your product. So what are the factors you should consider? Okay, so that you will be studying in design of X. So anyone has any doubts today regarding today's class?
No doubt, sir.
Wait for 2 seconds. I will be taking the attendance. Okay, if you do not have any doubts, then you can leave the class. Don't leave now. Okay. Okay, Shun, thank you. Okay, you can leave the class. Thank you very much.
Thank you, sir.
Thank you. God bless you.